Hello friends, welcome to my channel. So let's have a look at problem 128 together again. Longest consecutive sequence. So in this video, we're going to share a solution using union find. So this solution actually is inspired by a solution to problem 2334. So actually when I look at problem 2334, I first shared a solution using monotonic stack. So afterwards, I saw this solution for problem 128 using the set and check. So you can see the corresponding video in here. So when we examine this method, so we sort of cook up a method for solving problem 2334 using union find. And actually after solving 2334 using union find, it actually inspired me to look at problem 128 here again using union find. So this is the goal for us here, in other words, to provide a solution using union find for the current problem. So this is actually a continuation for the second question we asked when we do the video for problem 128 using set and check method. That is, think of the way we find the root in union find. So here, if we want to use union find, so essentially the idea are the same as the set and check solution, but the idea is find the largest size of the clusters that contain consecutive elements, right? So the item 4 here is an example of procedure for this idea. So basically, we first convert this nums array to a set. The reason is that equal elements do not produce consecutive elements. Then we want to partition this set into different clusters which contain consecutive elements. For example, for this example, the clusters are the following three. So 1, 2, 3, 4, 100, 200. So we return 4, which is the size of the first cluster. So the union find and data structure actually suit this problem also in a natural way. So here we're going to implement such a data structure and then apply it to the current problem. So first I'm going to implement the disjoint set union outside as a class outside the solution class, so that it can be used as a general purpose tool. And then we look at the solution to this problem. So actually the implementation of disjoint union is sort of straightforward, and there are different variants. For example, how we do the initialization and how we do the find. So there are two different versions basically. One is the vanilla find, and one is the find by using path compression. So another is the union. So there are also two different versions or classes, like the vanilla union, and also the other is the union by rack. So here I'm going to do the implementation. I'm going to implement using vanilla find and a union by rack. So here the rack is going to track the size of the clusters. So with that said, let's do this implementation quickly. So this is the sort of standard. So class disjoint set union. So let's first do the initialization. So self. So I'm going to initialize parents and size. So self parents. Let's use plural form. So self sizes. So it's also a empty dictionary at the very beginning. So now let's look at the find. So this find self x. So here in this problem, x will be a number in the set after we transforming the nums array into a set. So depends on the use cases, this x it can be different things. Select the indices in problem 2334. So first I'll check if a case is if x not in self-parents. So in this case, I'm going to add this x to the attribute. So self-parents x equals x, and self sizes of x equals 1. So this, at the very beginning, x is a single element cluster. So otherwise, what we are going to do is that I guess here we can add a return or just a week. So for example, we return x. So you can also ignore this, but for our purpose here. So in the second case, I'm going to return x if x equals its parents or its root. Otherwise, I'm going to make a recursion call and apply this to self-parents x. This actually forms the chain or recursion relation. So with that said, let's quickly do the union. So it accepts two arguments besides the self. So first, I'm going to track the roots of x and y. So that is self find x, self find y. So now x and y represent the root of the original x and y respectively. So we are going to do work if x and y are not in the same cluster. So if x does not equals y, so meaning the original x and y are not in the same cluster. So we're going to do the reset of parents or root according to the rec. So if self sizes x is greater or equal than that of y, so I'm going to set self parents, the parents of y, to be x, and then I'm going to increment the size of the cluster represented by x by adding that of the sizes of y. So this is one case. In other case, basically we do the reverse. Let's copy this part. So in this case, the rank of y is larger. I'm going to set the parents of x to be y and increment the size of the cluster represented by y by adding that of x. So with that said, we finished the implementation for the union method. So for this problem, that's actually these two methods are sufficient. But for getting for the purpose of gaining a better understanding, I'm implementing another method called get clusters C. So this will help us visualize the clusters in the final state. So for this, I'm going to iterate for kv in self parents items. So I'm going to first track the root of v, the self and v. So then if root not in D, so I'm going to D root equals this set, a single element set. Otherwise, I'm going to add this element to the set corresponding to root. So then I'm going to return this D. So this is a helper function, and the main function here are the find and the union for our problem. So with that said, let's do a quick check to see if this is correct. Then we look at the problem or solution to this problem here. It's very straightforward then. So we parents size. So if x not in, we're going to set parents x equal x, size equals 1. So here we choose to put a return x. Otherwise, we are going to see this. find. So here y x x x y. So yes, that's it. So now let's look at the problem. So then first we're going to make this numbers a set, or more precisely, we make a set aux out of nums, right? Then we're going to initialize the result. So basically it represents the size of the possible clusters due to the assumption that nums can be empty, so we initialize it as 0. Then we're going to instantiate a disjoint union, disjoint set union, DSU, and then we traverse the set and trying to do the merge or union operation. So for y in AUX, then I'm going to first do a find, DSU find this y. So we want to first add this y to the data structure, and then we do the check. So if y minus 1 in DSU, then this y minus 1 and y can merge, right? So basically we do union y minus 1. Similarly, we check y plus 1 in DSU. So then this can also merge, union y plus 1. So once we finish this union, so basically we can check the size, right? Size, meaning the cluster containing y, right? So first we check the size, DSU sizes. So we need to find the representation of this cluster containing y. So that's, we want to find the root. We want to find the y, right? So then with that said, we're going to update the state of result because we are trying to find the longest chain. So we're going to do this, and then we're going to return the result finally. So that's a full solution. So we see that the structure is like this. We first implemented a disjoint set union data structure, and then we try to do the merge after we instantiate a such data structure. So in order to make the elements consecutive, we check for a fixed y minus 1 and y plus 1, that is its neighbors, and then we update the result in the process, and finally we return the result. So let's do a special case check. So here DSU, the argument DSU is not iterable. So here let's see if y in DSU parents. So let's test again. Similar here. So it passes the first example. So now let's look at the generic case. It passes the generic case. So in order to gain more information, so let's have a look at example 1. So I would like to print out the clusters. So I'm print, so DSU get clusters, right? Get clusters. So let's see what's the cluster corresponding to the first example. So we have 3 clusters. So the return is 4, the size of the first cluster, whose root is 2 or represented by 2, right? So this is example 1. So we can also do a check for example 2. So we have 1 cluster, so it's for 0, 1, 2 up to 8. So the return is none. So with that said, I guess that's about it for the solution and the solution structure. So it would be good if you have time and then look at problem 2334 for the two solutions and compare with the solution here. Or you can look at the original solution we provide for using a standard set and check for this very problem. With that said, it's the end for this video. Thank you very much.